Number 21. Every few years, winds in Boulder, Colorado attain sustained speeds of 45 meters per second when the jet stream descends during early spring. Approximately what is the force due to the Bernoulli effect on a roof having an area of 220 square meters? Typical air density in Boulder is 1.14 kilogram per cubic meter, and the corresponding atmospheric pressure is 8.89 times 10 to the 4 newtons per meter square. All right. And it says assume laminar or whatever, blah, blah, blah. All right. So here is a roof. Okay. Now let's just assume that the velocity of the wind is hitting it directly. Okay. Meaning it's not like grazing above it. It's hitting it head on. All right. You could have even drawn it, I guess. I guess it would have made more sense to draw it from above, but it doesn't really matter. Just know that it's hitting directly, meaning that the normal with respect to the normal of the vector of velocity with respect to the plane here is 90 degrees. And we also have then the density of the atmospheric air, right? It says air density, and then here's the pressure. So how are we now going to calculate the force? Well, let's think about it. Do we have any force on here on the right-hand side? No. So I guess right, all those equations go out the window. We're going to use them, but not right away. So we're talking about pressure and so on and so forth. So maybe, right, maybe, just maybe, we're going to use this formula. That pressure is equal to force divided by the area. Right? I know the area of the roof. So in order to find then the force, I have to know the pressure applied to the roof. Okay? Now, the important pressure here is basically, and here's the thing, right? The force applied to the roof. So basically, we're trying to figure out the force that exceeds atmospheric pressure. All right? Doesn't state that in the problem, but this is essentially what we have to calculate. So I'll write this. Excuse me, it almost sounded like I started to cry, but while I'm doing all these problems, I do cry internally, but hold on. I need a drink of water. Let's get started. So here, we're going to have the force that exceeds that of atmospheric pressure. And if that's what I'm interested in calculating, then I have to calculate the pressure that exceeds atmospheric pressure. Okay? So let's think about this. Let's think about Bernoulli's equation down here. I'm not going to write the whole thing out. I'm just going to cancel some things on the bottom as we go. So in other words, okay, this roof, okay, is experiencing a pressure, okay, due to the atmosphere. And it's also experiencing a pressure due to, or an increased pressure, right, due to the velocity of the wind. That should make sense, right? I mean, have you ever been out, a windstorm, right? Big gust of wind hit you. It applies some pressure to your body, right? Because it applies some force. So basically what we need to do here is we need to take the absolute pressure, which is going to be the atmospheric pressure, and add to that essentially the kinetic energy per unit volume here, all right, which is essentially a pressure, okay, but that relates the density to the velocity of a certain moving fluid, okay? So we do know these two, right? We do know these two. We have the density of air, and we know the velocity of that air. So therefore, we could find essentially the pressure applied with the air. Okay? There is no change in height here, right? So there is no height really aspect to this, so that I can cancel. Now on the right-hand side, okay, what I'm solving for is I'm going to be solving for P2. That's my goal. Here is atmospheric pressure. But remember, if I take atmospheric pressure and add to that essentially the pressure that the wind exerts on this roof, then I can find the total pressure of, I'll call this now, this is the pressure of the atmosphere plus the wind. Okay? That's going to be at point 2. That's right, that's the location of the roof. And there is no velocity. The roof isn't moving, right? So that's gone. There is no height change, so that's not present. Okay? We can assume that, or we can assume this, that the velocity of the wind, once it hits the roof, it stops, right? That would be a better way to phrase it. So in that case, that cancels. There is no height differential, so that cancels. So basically what we're left with here is going to be P1 plus 1/2 rho of the air times V1 squared is going to be equal to P2. Using my subscripts now, this is the atmospheric pressure plus then 1/2 multiplied by the density of the air multiplied by the velocity of that air squared will equal then the pressure of the atmosphere plus the pressure applied by the wind. Okay, so let's calculate. So this is now going to be 8.89 times 10 to the 4th. Let me write this a little neater. Times 10 to the 4th plus 1/2 times the density of that air. They told us it was 1.14 times the velocity. They told us it was 45 squared. And that's now going to equal the pressure of the air plus the wind. So let's calculate. So it's going to be 8.89 times 10 to the 4th plus now 0.5 times 1.14 times 45 squared. So here we get a value now of 9.0001, I guess if I'm going to round, times then 10 raised to the 4 times 10 raised to the 4th. And this is now in terms of Pascal. All right. Or I could have phrased it as newtons per square meter. They are the same thing. So that's going to equal the pressure of the atmosphere plus now the pressure applied by the wind. Now, remember, in order for me to calculate the force on the roof, I need to calculate essentially basically it's just the force. And I could have actually just left this out, and that would have been probably a little easier because now I got to subtract it out. But I just wanted to do this calculation because I wanted to show you that this is essentially the total pressure applied to the roof, but the roof is surrounded by the atmosphere, right? So not only on the top is the roof experiencing this amount of pressure, but also it's experiencing that same amount of pressure from the bottom, right? Because the house is in the environment, right? And we're assuming that there's atmospheric air inside the house. Okay, it's not a vacuum. That being the case, this basically cancels itself out, right? More or less. Okay, so in other words, if I want to find now just the pressure of the wind, because that's all that's really making the difference here, I'd have to now subtract out the 8.89 times 10 to the 4th, right? Times 10 to the 4th Pascal. So this would essentially give me the net pressure applied by the wind, okay? So just subtract out that 8.89 times 10 to the 4th, and this would work out to be now 1.15 times 10 to the 3rd Pascal. And that is equal to now the pressure applied by the wind. Now, you could have easily just done this by simply not even including this in the formula, dropping this on out, and then you could have just used this to calculate the pressure that the wind applied. That would have been fine too. I decided to take the long road. We took the scenic route, okay? So now this is that excess pressure, or basically the pressure applied by the wind. So now when I'm thinking about my formula over here, now I can finally solve for that force, okay, that's applied by that gust of wind. So now we're going to do it. I'll do it up here on the upper right. So this now the force will be equal to that particular pressure, 1.15 times 10 to the 3rd, okay, because that's the additional excess pressure on top of that atmospheric pressure, multiplied then by the area, which they told us was 220 square meters. So just throw that into the calculator, multiply it by 220, and here we go. We get our answer of 2.54. 2.54 times 10 raised to the, what do we got here? 5, right? Yeah, 5. And that is in terms of now newtons. Okay, so that is indeed the answer. And hopefully the rationale made sense. I took a little longer way to go about it. I think it makes a little better sense, though, if we do it that way. But, you know, in the future, you don't have to. You know, you can take the more direct route. All right, guys, thank you so much for tuning in. Appreciate it very much. Hopefully this video helped. Please remember to help us out and subscribe. We'll see you next time. Thank you.